Recitation 12. So a finite meaning sequence. So here we have this equation. This equation, somehow you can think as a function, but the function, the variable, the value of the variable only takes whole number, as input. So what I mean is this. You could think of this as f of x. F of x equals to, for the numerator, we have x squared. The denominator, well, x squared is a quadratic function, the numerator, right? The denominator will have exponential functions, 2 raised by x plus 1. So one way to think about sequence is this. Right, but in here, the difference between this and the function is, you see n. So if we look at this as a function, so the domain of this function is all real numbers. So x can be any real number in this case. But in sequence, n can only be whole number in this case. Sometimes we want n to be a natural number, but in this case, n can be 0. So n is any whole number. What is a whole number? Whole number start from 0, 0, 1, 2, 3, 4, 5. So basically counting number plus 0. Right. So one way to think about sequence as a function, but it takes the special input. So input can be whole number or natural number or counting number. All right, so here we want to write out the first 5 terms. So it's similar to evaluate function value, right? If we really think of this as a function value, in this case, we know how to evaluate, right? We can evaluate f of 0, right? F of 1, f of 2, f of 3, f of 4. So 5 terms for first 5 terms. Right, so there's 5 terms. So when we evaluate, we just plug in the value of 0 into the x position, right? For the first one, we would get, well, the numerator is 0 squared. As long as the numerator is 0, so we know the expression is 0. For the second one, x equals 1. So the numerator have 1 squared, which is 1. The denominator have 2 raised by 1 plus 1, which is 3. So we get 1/3. So we do the same for this sequence. So sequence, but we write it in different ways. So let me use a pencil. So we would write it as A0. Usually we don't call A0, we call A0. A0 in mathematics. So we just evaluate n equals 0. So we would get 0 squared in the numerator. Denominator have 2 raised by 0 plus 1, right? As long as the numerator is 0, so we know the expression is 0. So A0 is 0, the first term. The second term, A1. A1, we have 1 squared over 2 raised by 1 plus 1, which is 1/3. Okay, you see it's the same as the function. So A2, we just plug 2 for n. So we have 2 squared in the numerator, 2 raised by 2 plus 1 in the denominator. 2 squared is 4, 2 squared is 4 plus 1, that's 5. So then the first term will be A3. A3, we have 3 squared in the numerator, 2 raised by 3 plus 1 in the denominator. 3 squared is 9. 2 raised by 3 is 8. 8 plus 1 is also 9. So that equals to 1. And the A4, the fifth term, is a 4 squared in the numerator. Denominator will have 2 raised by 4 plus 1. 4 squared is 16. 2 raised by 4 happen to be 16 also, 16 plus 1. So that's 16 over 17. So these are the 5 terms. Usually we can write like this. We can write as 0, 1/3, 4/5, 1, 16 over 17. So these are the first 5 terms of this sequence. Okay. So AN is a general term. It's a general term. All right, so that's for A. So similarly, let's see for B. B, we want to evaluate B naught, first term. Numerator will have -1 raised by 0 divided by 3 times 0 plus 1. So -1 raised by 0 or anything raised by 0 is just 1. 3 times 0 is 0. 0 plus 1 is 1. 1 over 1. So the first term is 1. The second term, B1. Right, okay, -1 raised by 1. We just substitute n into 1. 3 times 1 plus 1. So -1 raised by 1, that's negative. So 1. Usually we write negative sign up front. 3 times 1 is 3. 3 plus 1 is so -1/4. The third term, -1 raised by 2. 3 denominator of 3 times 2 plus 1. -1 squared is +1. 3 times 2, 6. 6 plus 1, 7. Well, fourth term would be 3. Or -1 raised by 3 divided by 3 times 3 plus 1. -1 raised by 3 is negative. -1. So -1 over 3 times 3 is 9. 9 plus 1, 10. So -1 over 10. Or b to the fourth power, which is b to the fourth, b4, which is the fifth term. We have -1 raised by 4. In the numerator, denominator, we have 3 times 4 plus 1. -1 raised by 4 or -1 raised by any even number, that's +1. 3 times 4, 12. 12 plus 1, 13. So the first 5 terms is we have 1 -1/4, 1/7, -1 over 10, 1 over 13, dot, dot, dot. Maybe sometimes we write the nth term. All right, so those are the first 5 terms of this sequence. And we see this sequence is the alternating sequence. We have a positive term, negative term, positive term, negative term. It's called alternating because it's -1 raised by n. Let's see C. So C naught is -1 raised by 0, 2 times 0. You know, as long as the numerator is 0, we don't really have to evaluate anything else. So we get a 0 right away. So first term is 0. Then C1, second term of -1 raised by 1, 2 times 1. Denominator will have 3 raised by 1 plus 1. -1 raised by 1 is just negative. And numerator will have 2 times 1, which is 2. Denominator will have 3 raised by 2, which is 9. So second term is -2 over 9. Third time C2 of -1 squared, 2 times 2, divided by 3 raised by 2 plus 1. -1 squared is 1, so 2 times 2 is 4. Denominator will have 3 raised by 2. 2 plus 1, or 2 plus 1 is 3. 3 raised by 3 is 27. So the first term is C3 of -1 raised by 3, 2 times 3, and 3 raised by 3 plus 1. -1 raised by 3, we get a negative term. 2 times 3 is 6, divided by 3 raised by, well, actually 2 times 6, we don't have to evaluate. Let's keep as 2 times 3. Because the denominator will have 3 raised by 3 times 3. 3 divided by 3, so these two cancel to be 1. So we get -2 over 3 raised by 3, which is 27. So the first term is -2 over 27. Fifth term, which is C4, get -1 raised by 4. 2 times 4 divided by the denominator is 3 raised by 4 plus 1. -1 raised by 4 past 1. 2 times 4, 8. Then 3 raised by 5. 3 raised by 4 is 81. 3, then 81 times 3 is 243. This is 8 divided by 243. So the first 5 terms for this sequence is also alternating sequence. We have positive, we have negative. Actually, 0 is neither positive nor negative. So get negative from the second term. We have negative, we have positive, we have negative, we have positive. Right. We call this alternating series. So those are the 5 terms of this sequence. Sequence, not series yet. Let's see D. D, let's say A naught. So have E. E is called the Euler number. It's about 2.718. It's an irrational number, just like the number pi. We can approximate, but the E doesn't have exact value. So we just keep as E. We call Euler number. So 2 times 0 divided by 0 raised by 3 plus 3. So 2 times 0 is 0. E to the 0 power is anything to the 0 power is just 1. So we get 1/3 as first term. Second term, A1, where E raised by 2 times 1, this is 2. Then 1 raised by 3, just 1, 1 plus 3. So we have E squared over 4. Sometimes we write it as this, as a quarter of E squared. Doesn't matter which way you write. Third term, A2, we have E raised by 2 times 2, which is 4. And denominator, we have 2 raised by 3, which is 8. 8 plus 3, we get 11. So A3, we get E to the 2 times 3, which is 6, E to the 6. Then 3 raised by 3, 27. 27 plus 3, you get 30. So A4, the fifth term, will be E raised by 2 times 4, which is 8. Denominator will have 4 raised by 3, 64, plus 3, 67. So those are the first 5 terms. We have 1/3. We'll have E squared divided by 4. We'll have E to the 4th power divided by 11. We'll have E to the 6th power divided by 30. We have E to the 8th power divided by 67. Dot, dot, dot. Okay, first 5 terms in this sequence. Let's observe a little bit, right? You see the numerator, if we take a look at, from the point of view of the functions, this is an exponential function. And the denominator is a polynomial function of degree 3, or cubic function. Okay. All right. Now let's see the other way around. Now we're given a couple of terms in the sequence, and we want to form a general term. General term usually we could call A and B and C and whatever, but in this case, let's call it AN. So we want to figure out AN. AN we can think as a function of N. All right. So the only thing appears is a variable N. That's our goal. All right, we want to write AN in terms of N. Well, let's see this big. So we have 80, 74, 68, 62, 56, which the numbers is decreasing. So from 80 to 74, there's a subtraction by 6. 74 to 68, also subtract 6. Okay, so this is called an arithmetic sequence. Arithmetic sequence will have a common difference, or common difference in this case we call it D. It's a -6. So which means the nth term is just the previous term and minus 1 term, plus d. But in this case, it's plus -6. You can write it as, you know, the previous term subtracting 6 will be the current term. But an equals to an minus 1 minus 6. We need to figure out an minus 1 because we want to represent this one in terms of n. So we see we start with 80, right? So that means an can be written as 80 minus 6n. Look at this. So from 80 to 74, the minus 1 times 6, right? So minus 6 times 1. And then from 74 to 68, minus another -6. So which means from 80, the third term is 80 minus -6 times 2, minus 12. So on and so forth. That's why the general term is an equals to 80 minus 6n. In this case, we want the n to be counting number because we start with 1. Or maybe you say, okay, I want to work with a whole number. I want n start with 0. If n start with 0, we have to change an a little bit. Right? We have to say, okay, that's 80 minus n plus 1 times 6. Right? Because n start with 0. The first term is 80, the next term is 74. If we start n with 0, we have to do n plus 1. And we can simplify this a little bit. So we say 80 minus n minus 6n minus 6n minus 6, which will get 74 minus 6n. Yeah. Oh, n minus 1, sorry. N plus 1 wouldn't work. N minus 1. Because in the end, we want the n plus 1. So in this case, we want to do n minus 1. So that's why here we get n 80 plus 6. So 80 plus 6, that's 86. No, that's not right either. Okay, so so we want the nth term. So 0 term. So basically, we need to figure out 0 term. 0 term has to be 80, right? 80 minus 6n. Oh, okay, you know what? Still 6n. Because if the first term has to be 80. Actually, yes, this one we start with 0. Okay, forget about it. So indeed, so if we made an equals 80 minus 6n, that's n start from 0. If we want n start with 1, we need to do here n plus 1. N plus 1. Then the next term will be 74. All right, so that's the general term. Now let's see B. B, we have 3. First term, next term 1, 1/3, 1/9, 1/27. So from 3 to 1, we multiply by 1/3. 1 to 1/3, we did the same thing, we multiply by 1/3. So you see every term is just 1/3 of the previous one. So this is called a geometric sequence. Geometric sequence, we have a common ratio called R. In this case, R is 1/3. So if we call the general term an, the next an is 1/3 of the previous term. 1/3 of the previous term, right? But we want to write this one in terms of n. Our first term is 3. You see, the first term is important. Okay, first term is 3. So we would get 1/3, because each term we multiply by 1/3. That would be 1/3 raised by n, then times 3, right? You see, the first term is 3. The second term is 1. So when n equals to 1, when n equals 0, anything times raised by 0 is 1. 1 times 3 give us first term. When n equals 1, we have 1/3 times 3, which is give us 1, the second term. So we can rewrite this. So 1 over 3 raised by n can be written as 3 raised by negative n times 3, or 3 is 3 raised by 1. So we can write this one as 3 raised by 1 minus n. So that's our general term, an equals to 3 raised by 1 minus n, or 3 divided by 3 raised by n, right? And also we need to define our n start from 0. N start from 0. So sometimes, you know, we want n start from 1, but in this case, we can start n with 0. Let's see C. Then 3 is the last question. So we observe 3 are also all fractions and is alternating, positive, negative, positive, negative. So in that case, we know negative 1 raised by certain power is involved. And the first one is positive, so that one means maybe we want to do n plus 1. N plus 1, also we want n's. Oh, you know what? We can do n. Let's start negative 1 with n. Then we want n start with 0, because anything raised by 0 give us just 1, positive 1. So then this first term will be positive. The second term will be negative 1 raised by 1, so we get a negative. So we have fractions, and if we try to find a common difference, it won't work. There's no common difference. If we try to find a common ratio, and there's no common ratio, so which means this sequence is neither arithmetic nor geometric. So we have to deal with denominator, you know, separately, and the numerator separately. So let's see the denominator. So 5 to 11 to 17 to 23 to 29. 5 to 11 is add 6. 11 to 17 is add 6. 17 to 23 is adding 6. 23 to 29 is adding 6. So the denominator is a arithmetic sequence. So the common difference is positive 6. So if you want to write that and the n start from 0, so we'll write the denominator as the first term, also very important, is a 5 plus 6n. So n start from 0, like 6 times 0 will be 0, 5 plus 0 will be 5, that give us the first denominator. So the denominator we want to write as this, 5 plus 6n. The numerator we observe, we have from 4 to 8, 8 to 16, 16 to 32. So each time this multiplied by 2. So the numerator itself is a geometric sequence. The common ratio is multiplied by 2. Right? And the first term is 4. So that means we can write it as starting with the 4 times, we also have negative 1 times raised by n, because we want n start from 0. Then 4 times 2, right? But the second one, we see 2, so 2 raised by 1, 2 raised by 2, because 2 raised by 2 is 4. 2 times 2 times, like 2, okay, we want to do 2 raised by n also, because n start with 0, 2 raised by 0 will give us 1. 1 times 4 give us the first term. Then n equals 1, give it 2 raised by 1, 2 times 4 is 8, give us a second term. So on and so forth. So the numerator, so we have negative 1 raised by n, 2 raised by n. We can write together as a negative 2 raised by n's power. Then multiply by 4. 4 can write here. So now the numerator, so the n's term, the general term in terms of n, the numerator is a geometric ratio. So we can write 4 up front, or let's write a negative 2 up front. Negative 2 raised by n, then multiply by 4. The denominator is this arithmetic sequence. It's a 5 plus 6n. Right, so this is n. all right? So this is a general term. The numerator is a geometric sequence. The denominator is a arithmetic sequence. So we figure out, separately. Now let's see 3. 3, we're given this 1, 2, 3, 4, 5 terms. So it's alternating. Whenever we see that alternating, we know -1 is involved. And the first term is positive. So let's write n start from 0. So we have -1 raised by n involved in the sequence. The first term is 4. The second term is -9 over 2, 16 over 3. Oh, okay. So the first term we can think as 4 divided by 1. So the denominator will have 1, 2, 3, 4, 5 consecutive. So the denominator we can write as, because our n start with 0, so we want to write as n plus 1. 0 plus 1 is 1, right? And the numerator will have 4, which is, we see this perfect square, 2 square, 3 square, 4 square, 5 square, 6 square. But the first term is 2 square, so that's n plus 2, because our n start from 0. Right? Then we have this -1 raised by n. So this -1 raised by n. So that's our general term. General term is -1 raised by n plus 2 square divided by n plus 1. Now we want to find the 30th term, which is a, well, our n start from 0. So 30th term will be a29. That equals to -1 raised by 29. Then 29 plus 2 squared divided by 29 plus 1. Right? -1 raised by 29, which raised by odd numbers, will get negative. 29 plus 2, 31 squared. And the denominator 29 plus 1, just 30. So what's 31 squared? 31 squared is 1 times 1 is 1. 3 plus 2, 3 times 2, or 3 plus 3 is 6. 3 times 3 is 9, so 961. So the 29th, or the 30th term. So A29, which is the 30th term, equals to negative 961 divided by 30. Okay, that's all. That's recitation 12.